Hello, my name is Penny, and I am going to explain the AWS design implementation of the cloud for our subject cloud computing. My name is Penny, and I have my groupmates with me, Somu Khadka, Sayam, and Somya. Okay, so we have aimed to implement the design solution, various aspects of security and technical planning, and the cloud security model configurations. And here is our agile sorry, agile development cycle. So it starts with the project, then the product, then sprint, and then release. Then we again goes on sprint, and then we deliver the product. And here is the better understanding how we do each steps. So I would be explaining it through the AWS console. So here we have our VPC. So we have created the assignment to VPC and the network gateway to VPC. I will show you some of the details for them. Yeah, the resource map C, VCR, and all. The next we have created are the subnets. Some of them were automated made. I just created one which is private subnet, and we have attached everything with this one. Then the next one I did was the routing table. We have created the this network gateway public. There are public, private, and all the routing tables which are here. The Okay, so this is some of the details for it. Route the routing tables and the subnet association for that one, which is with the gateway one and gateway one itself. Yep, the next one I'm moving is this one, the internet gateways. We have two internet gateways as per the two VPCs that we have created. Then the next one is net gateways. We have created two different net gateways, both for the public and with the different IPv addresses, and they are also attached to different subnets. So these are the details of it: the secondary IPv address and all the things are attached to a tag which is named as a name, which is netgate, and the value is netgate one. All the things. Then we have the security group, which is assignment 2. Here we have given one inbound and one outbound rule, which is the inbound rule is it's for the all security, and outbound rule is also for all the security groups which are here. The VPC which we have created, there are 5 subnets in one of them, 4 in other, and 3 in one of them. Then it will also show the the subnet allocations and the rules. Then the next one which we have is a virtual private gate, which we have done is with our assignment. Here are some details for it. And the last one which we have done is the distribution, which is I sorry the name, the ARN that we have given, and that's it. Security, the origin, behavior, and that's it for my part. Thank you.
Thank you. This is Somu. Today I'm going to explain my part in AWS that we created for our assignment. Today I'm gonna explain the storage and database. Here I have made a presentation slide First, I'm gonna show AWS Elastic Block. Second is AWS Relation Database Service. Third one is AWS Simple Storage Service S3. Fourth one is AWS Key Management Service, and lastly AWS Artifact. And in the second slide, I'm gonna say what EBS means. Like EBS usually helps to block the storage service, which is suitable for the database and highly availability external drive. So uh we don't need to be stressed over the like drive or anything. And next one is RDS. RDS is mainly used mainly arranged in the tables with links. It is useful for the database management in the financial application. It is one of the more popular database. Next one is R3 table, Amazon, and in this table, services for object storage has make the limited storage, which will utilize for the backup of the EBS and the RDS. So this is really important so that it will really keep the backup for EBS and EDS. Next one I'm gonna explain is QLBR, KMS, and Artifact. QLBS is also a database that we use in the Amazon AWS. It is the verified transaction log which monitor changes over times for the financial application. So we don't need to be worried. It will help a lot to keep the database of many things. Next one is KMS. So KMS is also helps to maintain the cryptographical key across the app in the different services. This is available in the Amazon, so you don't need to be worried about that. You can easily make the KMS key using the AWS. And next one is Artifact. Artifact helps to give the reports and the agreement center available OS and the other report acceptable to regulator and the auditor. It really gives the time auditor and every details that we need. Next one is I'm gonna show you first is like how I create the customer. First, I create a customer management services, which I already created. So I'm just gonna show you like this step. I already created this, so I don't need to create this back. So I'm gonna go back here, and when you check this one, you can directly see that I have already created the AWS manage key, which is required for our assignment. And second one is customer key management, which I already create, and we can see the policy key materials rotation and every details that we require, and the cryptographical configuration that we needed for us, and it gives the details of everything. Next one is volumes. So first we need to open the EC2 instance where we need to go to the volume. So I have already created the volume, so you can check here. So we have created the two volumes that it requires. When we click this one, it will it will give the details of this one, like every details that is shown here. So next one is I have created the snapshots. You can see the snapshots here. So here it's given everything like the time, product, code, owner, description, everything, and the KMS key ID as well. And next one is life cycle manager. This is the policy that we make. For here you can see the policy type, description, and this is only make for the like to keep the backup of our thing. And next one I have created is Aurora, like the database that we really require. First one I have created the snapshots where we can see this one and export in backup service and share everything. Second one is perform that. And yeah, you can see our snap thing. So here it's also, if we click, you can see the clear details and the time where we have created the snapshots. Next one is like AWS artifact, which helps to create like AWS artifacts, AWS artifacts. So this will so we need to open this page. Then we need to go to the view reports where we can see the many reports here. So if we click the yes, it can give you like like everything, every details, description, category, reporting period, title, and everything that we need. And this much from my side. Now I want to hand over to my friend for the next part. Thank you.
Hello everyone, I am Sumaya Azmin. Today I will talk about what I did using Amazon services, web services. IAM, which stands for Identity and Access Management. IAM is very important because it helps control who can access the system and what they can do. In this presentation, I will explain how I set up groups, permissions, MFA roles, and WAF to make the system more secure. Okay, so my main goals in this task were to strengthen security by using a centralized system for access to give users only the access they need, um, and to protect financial workloads from unauthorized access, and to integrate IAM with other security layers like VPC, S3, WAF. So yeah, so to achieve these goals, I followed a few simple steps. Like first, I created user groups. For example, an admin group, um, a backend group, and a finance group. Then I attached the right permissions to each group based on their role. I enabled MFA or multi-factor authentication for admin accounts to add extra security. I also created IAM roles to allow EC2 to access S3 securely without using access keys. Finally, I configured WAF to block unwanted um, unwanted IP traffic. These steps help build a secure structure for identity and access management. Um, yeah. So after setting everything up, I integrated IAM with services. IAM controls who can access VPC, S3, and other resources. MFA gives extra protection for critical actions. IAM roles make communication between services like EC2 and S3 more secure, and WAF provide extra security at the application layer. So this combination of IAM, MFA, and WAF creates a um, strong layer security. So while setting up the system, I face some small challenges. There were few MFA setup errors which I fixed um, by using a virtual MFA app. I also had a policy conflicts, which I solved by adjusting and refining permissions to follow the least privilege rules. And I faced some WAF configuration issues, but I tested IP rules to make sure everything worked correctly. These challenges helped me understand the tools deeply. And um, yeah, from this work, I learned a few important things that IAM is the foundation of cloud security. Adding MFA and WAF makes the system more secure, and using groups and roles save times and keeps permission cleans. Least privilege is a very powerful concept. It gives only what is needed. So yeah, IAM helps make auditing and compliance easier too. So yeah, and to summarize, I built a secure IAM environment by creating user groups, managing permissions, enabling MFA using roles, and integrating WAF. So this setup ensures that only the right people have the right access, and the system protected from the unwanted threats. So thank you so much for listening.
Hello everyone, my name is Sayyam Garg and my student ID is 256948833. Welcome to my presentation Cloud Security on AWS Network Implementation. In this demonstration, I will explain how I built a secure two-tier AWS VPC and show you the main configurations inside the AWS console. So the main aims and objectives of this project was to design a secure AWS VPC with separate public and private subnets, implementing Internet Gateway and NAT Gateway for controlled access, apply security groups and NACLs to enforce least privilege access, deploy Bastion and web servers with restricted connectivities. These are some of the basic tools. These are some of the basic scope and tools used. Like for this building, I used core AWS services like VPC subnets, internet gateways, NAT gateways, route tables, and security groups. And also I used these network ACLs and EC2. All tasks were completed in the N Virginia region using an Amazon Linux 2023 instances. And after that, I have checked that the main thing was the VPC was created. A VPC was created using a virtual private cloud with CIDR block value of 10.0.0.0 slash 16 value, which is a B class, provided the isolated networking for the project also. And as you can see, all of this is applicable and the opening was there. And as you can see, I will now show you the in the VPC console. And now you can see that VPC, and in VPCs I'll go there, and in this now my VPCs, you can see these VPCs available over here, and the state is available. So this was a VPC available. And after that, a public subnet was created. In that public subnet was created like the 10.0.1.0 slash 24, and the availability zone US East 1A for the Bastion host, and NAT gateway was there, as you can see in the screenshot also. And I'll just demonstrate that also, where it is there in the subnet sections. As you can see, the there is a public subnet available over here, and this is my public subnet. I'll check this. So subnet, this will show the CIDR values also. And one second, this is the latest CIDR values. So these are my public subnets which are created over here. And after this, I have also created a private subnet part, and this private subnet 10.0.2.0/24 hosts the internal web servers without direct internet access, ensuring the isolations also. And to access this, we will go here only in the subnet part, and the private subnet was this. One second. So this was my private subnet available over here. And now I will just go to the next slide. And I also that check that an internet gateway was created and connects the VPC to the internet, so public resources can communicate externally also. So as you can see in the screenshot also, it was created. And in the internet gateways, I'll show you that also. So this was the public gateway created, which was named at IGW0A64B, and as you can see in the there, and it is attached and it's like working also. So now I'll just go to the next slide, and in that, a NAT gateway was also created by me only, and I deployed a NAT gateway in the public subnet to allow private instances to reach the internet securely. So to access it, the NAT gateway, we will just go to the NAT gateway section, and here are the NAT gateways created. And yes, these are the some NAT gateways was created by Elastic IPs. And after that, the next in the next slide, we will go to the we'll also check. We have also created a public route table configured. The configuration for the public route table was to send the for public subnet to send all the outbound traffic 0000 through the internet gateway. So the public routing table was created, so we will go to the VPC, and in that we will see the routing tables. So these are some routing tables, and in this, the routing table is, you can see, this is the public routing table, and it is active at this time. So moving on to the next slide, I'll cover the private route table was also configured. So connecting this also, subnetting routing to the internet gateway and NAT gateway for outbound updates while keeping it isolated from the internet also. So you might see that private subnet was also created here over here, and you can see this is also active this time. And now also the security group for bastion host was created, and the SG bastion to allow the SSH port 22 only from my personal address, restricting all other inbound access. So it restricts the all outbound inbound access to other IPs. So we will check the EC2 instance first. In the EC2 instance, we will check the security groups. Just a second, it's loading. And we also made a security group over here. So one second. There are security groups were created, as you can see over here. So one is the security group for SG web, and one security group was created for SG bastion. So let me check which was the security group for that. Yeah, this was the security group which was created for the SG bastion. And moving on to the next slide, the security group for web server was also created, and the configuration for that SG web to allow the HTTP 80 from all users and SSH only from SG bastion for internal management. So as you can see that the internet management, so this was created for the SG web server, and it's all active, and it's allowing the permissions also. There were some rules which were entered over here. And so the public NACLs was also created, and the inbound rules were also defined, like you can see in the screenshot only. The inbound rules allowing ports 22, 80 and The range was between 1024 to 65,535 to enable web and SSH traffic into the public subnet. And the public NACL outbound rules were also created. So the outbound rules, as you can see, is we will go to the console, and in the console I will tell you. So in the NACL instance, uh, one second, in the VPC there are, so network NACL, network ACLs, in that the outbound rules for these are as follows. As you can see here, the outbound rules were predefined, and some access were given and some was not. So after that, we go to the next slide. Private NACL inbound rules were also predefined. Some of the, like you can see in the screenshot only, this is our ACL, and two subnets were associated, and the default was routed. And the inbound rules were saying that on the 100 roll number, all kind of traffic can come, but on the 110 roll number, the type was SSH 22 TCP 6, means six types of things were defined. And our IP 49.176.32.58.32 was also allowed. All other traffics were denied. This is the okay. And now the private NACL outbound rules were also defined in in the two subnet, as you can see in the screenshot also, and I will explain here also. So we'll go there, and you can see that all the rules were predefined, outbound rules also predefined, and the subnet associations will be these are the IDs. And after that, the EC2 instances was also launched. The EC2 instances were also launched, and finally both EC2 instances are running. The bastion host is the public subnet with the public IP, and the web server is in the private subnet without a public IP. So the user data script installed Apache and created a test web page automatically. So we can see the EC2 console over here, EC2, and we'll select the both instance. So there's some issues over here. So the EC, so in the screenshot, as you can see there, the EC2 console has converted western host, and web servers also were created, and their hostname type and the IAM role, instance type, and VPC ID, subnet ID, all things were available over there. And this was this. And the key highlights from this, we can say that, to summarize this: secure two-tier network isolation achieved, western access only for the admin secure shell, web server accessible only via internet and internal route, and implemented multiple layers of defense like SG plus NACL, the network ACLs. And the key learnings were learned: end-to-end AWS network security design, understood how routing and access control layers interact, and gained hands-on experience with Bastion host-based security. So that's all for my side. Thank you. Cloud security on AWS network implementation. Thank you all. Thanks. Bye.